The other day, I was doing some research on value objects and I came across this article, which I thought was really great. It is from the .NET Microservices Architecture ebook. I was doing some research and reading on value objects, and I came across it in these search results. And I thought the implementation of the value object they have in this article is absolutely brilliant, as well as the guidance for it. And the fact that it's just kind of buried in there under .NET Architecture and specifically actually .NET Microservices, I thought was really interesting. So we're going to take a step back and go through some very basic stuff. Let's brush up on it anyway, right? So a good example of a value object is some kind of object that has properties or values in of itself. It has no identity, and it has value equality and value semantics. So really simple examples of value objects are string, integer, uint, decimal, money, things of that nature. And integer is probably one of the most simple examples because 1 is equal to 1, 2 is equal to 2, right? 1 is the value, 2 is the value. Numbers are the value. Strings, string of text, hello world, is the value, and one string of text, hello world, is equal to another string of text, hello world. Not by reference, by its value. That's the main characteristic of a value object. Now, in context of plain architecture and domain-driven design, we start talking about domain modeling and things of that nature, we often come across these more complex objects in the real world that inherently have a variety of properties that together make up the value. So money, the value of money could be characterized, for example, as the amount as well as the currency type, right? USD, Canadian, $100. And address is the same. We have street, city, state, zip. Okay. And one address to be equal to another should have all the values, street, city, state, zip, equal to the other. Okay. So this article is pretty straightforward. Important characteristics of value objects. They have no identity. They are immutable, which is interesting, meaning they don't mutate. You would actually create a new value instead of mutating an already existing value, which makes sense when you really think about it. You can't really mutate the number one, into something different, because if you were to do something to the number one, mathematically, it doesn't become something different. You actually get a different value. 1 can never mutate to 2. 1 and 1 is 2. So kind of an interesting way to think about why value objects should be immutable. I would add to this article, though, that the third characteristic that they're missing, which is important, is the fact that they should have that value equality to them. So this implementation that they have was pretty slick. We're going to talk about how to improve it, but I want to go through it. So they actually did something I really, really liked, was they, one, created an abstract base class value object, because your value objects in your domain modeling should probably not really inherit from much of anything else, if anything at all. And 2, they implemented this get equality components abstract method, which I thought was really brilliant. And what they do is basically they override this in derived types. So if you were to have an address object and implement or derive it from value object, you would override get equality components, and they yield return each of the values that collectively make up the value of the value object. And I thought this was really cool. So we're going to implement this in my project, which is a financial application, but we're also going to improve it because there's some things that they are not doing in this example, which I feel like they should be doing. And we're going to go through that. So let's switch over to my project. Here we have a occurrence class. And in this case, just to walk it back, a person in this project is a domain entity, and it is also an aggregate root. It aggregates transactions, and a transaction can have a occurrence. Okay. And so the occurrence is how frequently the transaction occurs. Pretty straightforward. And there's different kinds of occurrences. It can be a one-time occurrence. It could be daily, weekly, monthly, annually. It can also occur a number of times, once, twice, and so on and so forth. It can also have an end date. Maybe the transaction ends at some point. So if we were to think about an occurrence, collectively, the name of the occurrence, the time unit, the times, and the end date make up the holistic value. We could argue that actually name should not be part of that. Maybe it's actually time unit, times, and end date are the value components. So we're going to implement a new value object-based class, and let's kind of get started and see how this works out. So public abstract class value object. We're going to do something a little bit better with our implementation of value objects, which I'm surprised they did not do. We are going to actually implement the IEquatable interface, which is per the Microsoft Framework Design Guidelines published many moons ago, the recommended way to implement equality. It doesn't change the implementation, but it does help. It provides us a typed quality overload. We still need to override the base method, but now we can return a call to the overload instead. So we still have one equality implementation. Still need to override get hash code and implement that. And we need to create our public abstract enumerable object. Get values method is what we're going to call ours. So what this is going to allow us to do is on our occurrence value object, we're going to derive from value object. We're going to implement the abstract class. And now per their example, we can just yield return the equality components. So we're going to return time unit, yield return times, yield return end date. And now up in here, we can implement, let's do our get hash code implementation. And so we're going to actually say IEnumerable object values equals get values. And then we're going to return values. And I'm trying to remember, I want to say we want to do aggregate x, y. So x would be the first value, y would be the second value. And we want to do x get hash code XOR y get hash code, I believe is the implementation. And then we want to cast this to an integer. Okay. So that's our get hash code implementation is pretty much done that way. And now we can do some additional checks. Now, I actually recommend if you're implementing equality, there is framework guidance on how to do that. So if we actually go IEquatable interface, I believe the documentation actually has a sample on how to implement it properly, because it's actually not necessarily for the faint of heart. So they have IEquatable person. And if we go down, so there's the object overload. It looks like they do check for null. And they also do a cast object person as person. And if that's null, I wonder why this is there twice, because this effectively does the same thing. Maybe it's a performance optimization. Maybe this is a little bit faster than actually trying to do some form of typecasting with the null check after, because there's also things like boxing and unboxing that could happen. Like if object is an int, I don't know if there's boxing or unboxing that occurs here, but that's an interesting perspective. But in ours, we're just going to delegate it off. Whether you want to implement it that way is up to you. And then in our method, we do want to do null check, because if it's null or the other instance is null, there's no point in doing the equality check at all, right? So if other null, return false, because we know there's nothing to actually compare to. We can also do another short circuit. We can actually say if other, actually object reference equals this other. If they're the same reference, we can return true, because they actually refer to literally each other memory. Like we can just do that. And then we can actually do our equality comparisons. We're going to say IEnumerable object, values, get values. And then for this, we actually are going to do return values sequence equal. And we're going to actually go up here. We need to do X values. And we're going to do Y values is actually going to be other get values. And then we're going to return X values equals Y values. And sequence equal should do the trick, because if we read the documentation, determines whether two sequences are equal by comparing the elements by using the default equality comparer for their type. And so that should do exactly what we want. So in the most basic sense, we have implemented a value object base class using the IEquatable interface. And let's go check to see if we've missed anything in either example, actually. So we're doing our value checks. That's fine. We did the get hash code, although we have multiple fields in our hash code implementation. And yes, we need to override the operators. So we need to do public. Remember the syntax, static bool. Is it override? Bool operator equals left and right, public static bool operator not equals left, right. And then we need to implement those. And so we can actually say return left. Well, left might be null, actually. See how they implement. So they do null checks. Person 1 is null, or person 2 is null. And they use object equals, which that's fair, I guess. So let's actually do return object equals left, right. That should probably, see, they got that ghosted out in the IDE. Correct method, simplify member access. Apparently just equals inherited from the base class. I'm assuming under the hood, this calls the underlying equality implementation. So we're actually looking at the system.object source code for that particular method, and we can see it actually does the null checks for us. But we don't particularly need to do our own null checks, I don't believe. And because this is going to call the overload of object on the actual object, it's also going to delegate to our interface method. So I think it all should work out. So in this case, we can just return the not equals version. So overriding the operators is absolutely critical for designing a value object, because it needs to be equal whether you are using the operators or the equality methods inherited. Both need to have the same value semantics. You don't want one that has reference semantics and another one that has value semantics. It would be very confusing to developers and consumers of your API which implementation of equality they should be using with your particular object. So effectively, we are done with value object. The only further way we could improve this, if we wanted to, which I'm not going to cover in this video, is we could also implement IEcomparable, which would allow the value object to be properly sorted within lists and hash sets and things like that. But maybe that's a video for another day. There's equal and great documentation on how to implement the IEcomparable interface. So to wrap up, we're going to go back down to our occurrence class. There's really nothing else we need to do here, but the other piece that we need to do is, the only other thing that we need to do is make sure this value object actually meets the design guidance for value objects, which is this needs to be an immutable type. So if we were to mutate this and allow the times property or the end date to be mutable, we would actually be changing an instance of the value to a whole other value. And so that would violate the guidance. So what we can do very simply with minimal breaking changes to this code is actually change our setters to init. So that way we can still provide the value in an object initializer, but only during initialization, thereafter being a read-only object. So if we were to build this project, we're going to get compiler errors wherever the usages were for that. We're going to go fix those as soon as this gives us the feedback we're looking for. And so we can see a couple places where we are creating occurrence or changing the values. So we actually create one, and then you can see where we assign the times. We're just going to create that object initializer instead and move that call up. So like little fixes like that are very straightforward. As we go through the rest, they're going to be similar. We're not going to worry about refactoring the code too much. There's some interesting code here. We're actually getting an occurrence from a repository class found by its lookup name. If it's not null, then it looks like we update the times value based on a request. This is probably coming from, an API. Okay, so what we're actually going to do in this case is just create the occurrence as a new value. And we're going to take, in this case, the name, the time unit, and we're going to say times. So we're copying the values from the previous value object up here. We recreate it here and then changing the piece that we need. So this is kind of the point. This value is different than this value. Now, in this case, we're utilizing the same variable, so we're overriding that location memory, but you get the drift. And so we're going to actually do the same thing down here, except the addition is we're actually setting the end date. Like so, and that takes care of that. And if I recall correctly, down here at the bottom of the project, there's a similar block of code. We're just going to paste right in. And let's go ahead and rebuild our project and see if we've resolved all the compiler errors at this point. And value objects are fairly straightforward to unit test if we did want to write a test for that. So if we were to add new item, let's do occurrence tests, and we could check the equality. So let's do, for the love of all things good, let's do a file scope namespace, public, do test class, test method. We're just going to call this quality test. Okay. Pretty straightforward. And we're going to make this a data test. We're going to create some primitives. So we're going to do new occurrence. We're going to give it a name. We didn't make name part of the equality, so this could be whatever we want it to be. And then time unit for the constructor, we're going to actually pass in. So time unit, I think the other one was times, and then there was also end date string. We're going to say end date string. Otherwise null. And then we can do our object initializer, time unit, and then the end date, like so. And let's see. Probably don't have a init enabled in the project. Maybe. Oh, never mind. We already set that through the constructor. So it's just those two there. And now we can say, let's do is equal 1. Let's do this through how do we want to do this actually? So we could create 2, I suppose. We would need 2 sets of parameters, I guess. Let's make this a little basic to start with, actually. Let's go ahead and occurrence 1. occurrence 2. Let's add some additional parameters. So time unit 1 times 1, end date string 1. And let's do time unit 2 times 2, end date string 2. And so that's going to be occurrence time unit. Let's just do a basic example. So day, 1 a day. Let's do no end date. And let's make this first one the equality. And we'll say bool should be equal. And in this case, should be equal is true. Let's start with one test. And then we're going to do occurrence 1 equals occurrence 2. Then we're going to say occurrence 1 equals occurrence 2. Using the object overload, we're going to say bool is equal 3 equals occurrence 1 equals occurrence 2 as occurrence, which is kind of redundant, but we want to be explicit for the test. And now we can say assert r equal is equal 1, should be equal, right? And we're going to check all 3. So this will identify any bugs in our equality implementation. The end date string 1, date string 1, end date 1, time unit 1, time unit 2, times 1, times 2, end date 1, end date 2, date 2, 2. That looks good. So we'll go occurrence 1, occurrence 2 for the names. Okay, let's rebuild that, and then we'll run the test and see how that turns. Okay, test. Occurrence tests, and it passed. So now let's add to our testing some additional parameters, and we'll change one little value, such as we'll change day to, let's do week, and now these should not be equal. Okay, so far so good. And we can change that back to day. Move this up. We could change a different parameter. So instead of that, let's actually change. Let's actually change. We're going to make the changes on the right-hand side, actually. So let's do 2 for the times. Passing. And let's do our end date, which is going to be a really big pain. So let's do null on the left. Let's do day 1. And then let's do today's date, be 12/9/2024. We'll just do that one last test. Run. And they passed. So very nice equality comparison. Very easy way to test for equality. We could also technically do the not equals as well. If we want to do the other operator, we could actually do not equal. Okay. And we could do is equal 4, which would actually be, let's just do is not equal for the operator as our last. Oh, we'll just put it at top actually. So now this should be the opposite of should be equal. is not equal. Like so. There we go. So there you go. This is a very simple, but in some manner of speaking, a very brilliant value object implementation. So kudos to the contributors and or authors of that .NET architecture, microservices architecture ebook article. The person that thought of implementing a value object-based class as a iterator design, I just thought that was absolutely brilliant. The value of this, no pun intended, to value objects is that now you can see that to implement a value object across your domain model, now all you have to do is derive from the base class, override, get values, and yield return your value equality components. You do not have to write all of this every single time you want to implement a value object, which is non-trivial to get it correct and also have it work as you need it to. So anyways, hope you guys really enjoyed this video. It was a shorter, simpler, sweeter video, back to basics, but hopefully making your frameworks and your code bases better through well-designed classes. Of course, go document the class with XML documentation comments, write your unit tests, make it really solid, put it in its own file and all that good stuff. As always, you guys are watching DX7 Dev. We'll see you next time.